Okay, we are going to finish up 7.2 in our notes. I am down at the bottom of page 8, I believe. Down at the bottom of page 8. The only new thing we're going to throw in here is dealing with rational expressions, where now not only are we going to have numbers under there, but we're also going to have radicals with variables. I'm sorry, we're going to have radicals with variables. So let's start off simple by talking about the fourth root of 81x to the 12th. Well, I'm going to kind of think about this in two different things. I'm going to take care of this number first and then this variable second and kind of put my answers together. Like the fourth root of 81, if you check our list, is 3. The fourth root of x to the 12th. Well, you can think about this several ways. Some people like to think of it as x to the 12 over 4, because remember, this index out here is always the bottom part of my fraction. So that will reduce to x to the third. 3x, 3. Done. Having something to the 1/3 power is the same thing as doing the cube root. So technically, this is the cube root of 8, a9b3, where the cube root of 8 is 2. Think about this as a to the 9 over 3, which is a to the 3. And think about this as b to the 3 over 3, which is b to the 1. Same thing with division. I'm going to split this up into the 6th root of y to the 12th all over the 6th root of x to the 24th. Think about this as 12 over 6, which is y squared. Think about this as 24 over 6, which is x to the 4th. Done. Okay, let's put a bunch of variables in there. If I've got 8x squared y6 z squared all over 4x 1/4 y5, I'm going to treat this as a bunch of separate problems rather than try to do it all at once, like these numbers out front, the coefficients. I'm going to take those and reduce them like a fraction to leave me with just 2. I'm now going to look at just the x's here. I've got 2 of them on top and 1/4 of them on the bottom. If you do your subtraction rule, because these are the same base, you'll end up with x to the 7 over 4 by subtracting 2 minus 1/4. Do the same thing with the y. 6 minus 5 is 1, so it's 1y left over, and there are no z's to cancel, so I got a z squared right there. Done. Cube root of 27 is 3. 9 over 3, because that's the same thing as x to the 9 over 3, which is x to the third. The only weird thing is this letter F right here. Now, what happens if it doesn't go in evenly? For example, the fourth root of 12. I don't know what that is. That's not on my list. So that just simply means that in my answer, you can have things that remain under this fourth root, like 12. Can't break it down in anything, so I have to leave it. This is d to the 4 over 4, which is a d. That is now on the outside, and since there wasn't any remaining, there's nothing left here on the inside. E to the 9 over 4. Oh boy. E to the 9 over 4. That is the same thing. And maybe the other shortcut you want to learn or you want to take into account is division. When you take a variable out of a radical, it's kind of like dividing this 9 divided by 4. Since 9 doesn't go into 4 evenly, that means I'm going to have some left here on the inside. Here's how you tell how many are left. If you take 9 divided by 4, goes in there twice. 2 times 4 is 8. You get 1. You get a remainder of 1. So, guess how many? This number here is how many I bring out, and this is how many are left. Whatever it divides to be, that's how many you take out. Whatever the remainder is, that's how many you leave on the inside. So, I take 2 e's out here, e2, and there's 1 left on the inside. And I'm going to do the same thing with f to the 14th. 14 divided by 4. So I'm going to 14 divided by 4. It goes in there 3 times, 12, 2 were left over, so therefore I'm going to take 3 of them out, and there are going to be 2 of them left on the inside. So I go 3 of them out, and 2 left on the inside. So they won't always work out to where everything cancels and there's nothing left in the radical. All right, let's do that with some division down here, and then we got to talk about some rationalizing of denominators as well. I'm going to split this first one. Oops. I'm going to split this example too. In this first one into the 5th root of x to the 10th over the 5th root of y to the 5. do my division. 5 divided by 5, that goes in there evenly, so I got 1 left down here. 10 divided by 5, that goes evenly. X squared over y. But what do you do if it doesn't go in there evenly, like this example? If I split this, I get the 5th root of g squared all over the 5th root of h to the 7th. Now, this g squared is not big enough to go into this 5, so I'm going to just leave it the way it is, 5th root g squared. But on this bottom, 7 divided by 5 is 1, so I could take 1h out, and there are 2 remaining, using the rules we had up here. But if you recall, back in the day, you are not allowed to have, let me highlight this, you are not allowed to have this radical in the denominator. So somehow we have to go through and get rid of that. Here's how we're going to do that. I'm going to take my 5th root g squared all over my h, 5th root h squared. I'm going to take this to another page to give myself a little bit more room here. And hopefully this works. No, of course not. Of course not. All right, I got to take care of this h squared. I'm going to multiply this by the 5th root of something. To figure out what I multiply by, I have to think to myself, okay, I have 2 of them right here. In order for those to cancel out and give me h to the 1 down here, I have to get to this power. I have to get to the 5th power. So since I have 2 of them already, to get to the 5th power, I got to go h to the 3. H to the 3. Why? Because h to the 3rd right here times this h squared will give you h to the 5th. And that is still under the 5th root. Don't forget your h out front. Multiplying across here, you will get the 5th root of g squared h3. Why did I do that? Because remember, the 5th root and the 5th cancel out. So I'm left with the 5th root of g squared h3 over these 2 h's turn into h squared. And now I'm done. So the weird part here was this concept. If you have 2 of them down here and you need to cancel them out, you better get to 3 because 2 plus 3 will give you this outside number of 5. We're going to take a look at the same example on this letter C. I'm just going to put it on a different page, but it's the same problem. All right, so same concept. I'm going to split this up to be the cube root of y squared all over the cube root of x to the 5th. I'm going to try to split when I can. This number is not big enough to take any out, so I just leave it as the cube root of y squared all over. This one is big enough, so I'm going to take 1x out, and there are still 2 x's remaining. So I have to multiply this by something, and it's going to be the cube root of something, cube root, to get them to cancel out. Remember, you want this number to be this number. You want these 2 to match. So since I'm 1 short, I got to multiply this by x. And if I do it to the bottom, I also must do it to the top. Multiply those together, I will get the cube root of xy squared over, this turns into x cube root x cubed, because I add this 2 plus this 1 right here to give me my x cubed. Whole reason I did that is so that these would cancel out, and I'm left with the cube root of xy squared over x and x squared. That is how you can rationalize a denominator if you've got some square roots left on the bottom with variables. All right, knowing that, we are now going to get into the bottom of page 8, dealing with adding and subtracting. We'll get to the checkpoint where you can try some of those here in a second. Adding and subtracting. Same concept as we've had on the previous video, 7.2, where this and this must be the same. You have to have like terms in order to put them together. So since I have 5 root y plus 6 root y, that is 11 square root of y. All I did is I added these 2 numbers out front and to get 11. And I kept this root y as root y. I do not add or subtract anything with the root y. Same concept here. 2 minus 7, negative 5. These are both the same, so I just drop it down to be xy to the 1/3. Yeah? All right, next page. Oops. What do we do if these are different? For example, 5x to the fifth and 40x squared, not the same. So if I'm trying to add or subtract them, I have to try to break these down so that they will be the same. So I'm going to break my 5x to the fifth using cube roots. Since I don't know what the cube root of 5 is, I know that's going to stay right here on the inside of my radical. But I can break down this x to the fifth right here. I can take one of them out, and there will be 2 left on the inside, because 5 divided by 3 is 1, with 2 as a remainder. Same concept here, except I can break 40 down, using what we did previously. I can break 40 down into be the cube root of 8 and the cube root of 5. Why did I choose 8 and 5? Because the cube root of 8 is 2, and I don't know what this is, so this stays on the radical. I cannot break down x squared because it's not bigger than this, so I can't take anything out of there. So all I'm going to take out is my 2. I have this x that's on the outside still, and what's left on the inside is my root 5, and I couldn't take anything out of x squared, so I leave it as x squared. May want to take a second and make sure you see where all this came from, because now the last step is going to be to put these together, because now this and this are the same. And I can add this and this. So I have 3x minus 2x, which is x. And I keep that yellow portion, the yellow height apart, I keep that the same. Oh boy. Whew. So that is how we can combine like terms, even if they weren't alike when we started. These last 2 examples, luckily for us, they are the same. This is cube root x, so if I got 3 of them minus 1 of them, I have 2 cube root x. And lastly, I've got 5x squared y 1/2 plus 7x squared y 1/2. Because this and this are the same, I can add these coefficients, to end up with 12x squared y 1/2. All right, last little part in section 7.2, and then I'm going to have you try this checkpoint down at the bottom of the page. If these are the same base, we add these exponents. The only weird part here is once you add them, there really isn't a whole lot you can do. So you could have an expression up here, meaning you might have a plus or a minus up above in your exponent. That is illegal. That's fine, because you can't add 3 plus root 5. Same thing here. This is power to power, so I multiply. I end up with y times the square root of 9, which is y to the third. You can multiply these radicals. And lastly, letter C, don't forget negative exponents. We're going to put those on the bottom. You can leave it just like that. All right, so what I want you to do is I want you to try these 5, and I believe your notes will also have a number 6. I believe it will have the square root of 121 z to the 5th. Mine doesn't have that, but I want you to try those 6, and I will put the answers to these online.